Okay, hello and welcome back to this session of Bioinformatics Bootcamp, Machine Learning for Biomedical Applications. So today we're going to be talking about intermediate Python. And just before we jump into it, I'm going to show really quickly how you get the code. This is going to be the same steps every time, but I like to go through it just to make sure everyone is on the same page. So the first thing you're going to do is you're going to go to our website, which is bigbioinformatics.org. So let's do that here. You're going to go here to workshops, and then you're going to go to Intro to Biomedical ML. And you can find here the GitHub workshop repository where you can download the code. So you go ahead and download that as a zip file. You can open that up in your file explorer, extract it, and now you've got all of the code and all of the resources for the workshop. Okay, so the next step is to actually, I'm going to just close all this here so you can see me do it from scratch. This next step is to actually open Jupyter Notebook. So I just come here to my programs, go to Anaconda, and I open it up from here. There's other ways to do it, but that's probably the easiest one on Windows. So I just go to where I downloaded the code to, which is this biomedical ML with Python main 6. And I open this up and I can see here module 1, module 2. Today is module 2, so let's go ahead there. And there's a few things in here today, but let's just focus on the module 2.ipy notebook for now. The challenge problems I'll explain at the end, as well as what this file here is. All right, so you should open it up and you should be seeing something that looks like this. All right. So let's go ahead and jump in here. I'm just going to double check that my screen is sharing correctly because I've made this mistake before. Okay, good. All right, so last time we talked about lists. That was sort of where we left off with things. And so I'm going to go really quickly and recap what we talked about. So basically, lists are a kind of complex data type or data object in Python. And basically, they are a collection of objects. They can be any kind of object that you want in Python. So for example, we could have characters, as you see here. And so we see when we make this list and print it back to the console, you can see it here like this. So it displays it. If we want to access the first element of that list, it's easy to do. You just use these square brackets and you put a 0 in there. Just a reminder that in Python, indices start at 0 instead of in R where they start at 1. So the first element is element 0. Okay. You can also access elements of a list using this start, stop, step notation. Okay, so that's called a slice. So if I've got a list that looks like this, I can access the second element through the fifth element using slice 1 through 4, remembering that the slice is not inclusive. So we get the the second element through the fifth element, but not including it. So that's 2, 3, and 4. Right? If we wanted to access the third element through the end of the list in intervals of 2, we could do 2 and then leave this blank because that means through the end of the list, and then intervals of 2. So again, that's start, stop, step, start at index position 2, go to the end of the list because we don't provide a stop, so there's no stop, and we do it in intervals of 2 or steps of 2. So we've got here starting at index 2, which is position 3. Again, you have to think in zero index notation. So position 3, which is C, that's index 2, right? No, going all the way to the end of the list. So no stop, we go all the way to the end of the list and we go in steps of 2. So we got C2 true. And that's what we see here, C2 true. Okay, finally, we showed how to reverse the order of a list. Basically, no start, no stop. So we get the whole list. And then we basically say in steps of -1. So that means going backwards. So you can see we've reversed the order of the list. We go false, true, and so on all the way to A. False, true, so on all the way to A. You can also get the length of a list using the len command. So this list is 8 long. All right, so before we move on from here, this is sort of our recap of what we talked about last time. Does anybody have any questions on this part here before I move on? Okay. Well, if you've got any questions, do feel free to put them in the chat, and I'll make sure to get to them the next time that we stop. All right. So one of the things that we didn't talk about that is a really useful. Oh, there is a question. Okay. So Anmol asked, how do you get the total number of elements in a list of lists? So are you asking about like a nested list? How do you get the total number of elements within? So, okay, so I think, and let's do this and then we'll go through that example here. So let's make a list. It's a fairly complicated one. It's got a lot of elements that are kind of confusing. And we can see here that it includes a nested list inside of it. So if we do len of my list, we can see it's 7. And that's because we only consider the top level of the list. We consider it to be first element, second, third, fourth. This whole thing is 1, fifth, 6th, 7th. And so when you do len, it just gives you the top level of the number of elements, because even though you have a list as one of your elements, this is still just considered one element. And so it doesn't add anything extra to the length of that list. If you wanted to get the number of elements in all the lists, including those that are nested, there's ways you could do that. I'm not familiar with any one line. Well, I mean, I can think of a one line way to do it that's kind of complicated for right now. But I'm not familiar with any functions that would allow you to do that more easily. If someone else is, though, please feel free to put that in the chat. That's an interesting problem, though. Okay, so let's talk about the in operator. Now, the in operator is actually just a logical operator that tells you whether or not some item is in a list or some object is in a list. And it's going to return true if it's in a list, and it's going to return false if it's not in that list. So for example, we see here 200 in my list. And basically this will be true if 200 is actually inside the list. And so we see right here, actually 200 is part of this list. So this should return true. And it does. If we made it 201, now it's false because 201 is not one of the elements in this list. Is hello list in my list? It's not. That's actually not in here. So let's make a quick challenge problem. Can anyone tell me, without running it, what the result of this will be? 22 modulo 7 in my list, considering that this is my list. Okay, so I see a couple trues here. Is that the final answer? Okay, very good. So why is it true? Well, let's start off with the first part of this, which is 22 modulo 7. If you recall, modulo is an operator that returns the remainder of a division. So 21 is divisible by 7. 22 has a remainder of 1 if you divide it by 7. So 22 modulo 7 is 1. Now, do we see 1 in this list? Well, yes and no. So we actually do see 1 right here, but it's in quotes, which means it's a string. However, we do convert it to an int right here. So that means we do have the integer 1 in the list. And if you actually look at the list, you see there's a 1 here. And so therefore, 22 modulo 7, which is 1, is actually in my list, which is why when we run this, it's true. Okay, so just a bit of a challenge problem there to get you warmed up. Simon asked, try 5 over 5 in my list. Okay. That's also true. Although I can't exactly explain why that one is. Well, I guess it's okay. So I suspect the reason is because Python can kind of think for you a little bit. So I'm guessing the in operator will also say that something is in something else by converting floats that could be converted to integers into integers, I assume. There's ways to test this. Unfortunately, for the sake of time, we don't have time to test it, but that would be a really cool thing to test if we get the time at the end. Okay, so let's go on now to range. Now, range is a function that basically returns a range object. And a range object is kind of it's very similar to a list in the sense that it's going to take all the numbers that are integers between two integers. So if we say here, it's got the same sort of slice notation, start, stop, step. So if we do range 0, 100, we get back, it just says back range 0, 100. That's because it's a range object. And when you print it to the screen, it doesn't look very helpful, unfortunately. And we can also do range 10, 23. That's the numbers from 10 to 20 in steps of 3. So this is not super helpful so far. Let's actually use in. So in doesn't just work on lists. It also works on ranges. Okay, so is 20 in range 0, 100? It is. What about 200? It's not. That's because 200 is not in the range of numbers between 0 and 100. Ranges can be easily converted to a list. Typically, you don't really need to do this, but it makes it easier as humans to see what's going on. So if we say list of range of 0, 10, 1, we see that is the numbers from 0 to 10, not including 10, in steps of 1. If we have list range 20, 32, we can see that is between 20 and 30 in steps of 2. So 20, 22, 24, 26, 28. If we don't supply anything except for 10, it's the numbers from 0 to 10, because the way that range works is it's start, stop, step. If you just supply one number, okay, it's going to just be the first one, which is start. Or sorry, it's gonna, sorry, I said that backwards actually. It's gonna be stop. If you don't supply a start and you don't supply a step, if you just supply one number, it's going to assume you wanted the start to be 0. It's a little bit confusing. It's just one of those things you have to sort of remember when you're using this. You could also just supply the start. It's not that hard to supply the start, to just say, 0 here. Produces the same thing. Okay. Okay, so I wanted to bring this up because we're actually going to be using this later in today's lecture, but for right now, just know that this is a method that you can use. All right, so another important thing to recognize is that you can actually convert between strings and lists fairly easily. And that's because Python actually treats strings as lists of characters. Okay, so this might say hello world, but actually it's kind of like a list object. It's sort of like a list object containing a list of characters in the order HELLO space WORLD exclamation point. And so if you want to access a particular letter, you can actually do that using kind of list accessing notation with these square brackets. So let's say I want to access the 5th element. 1, 2, 3, 4, 5, that's an O, returns back an O to us. Again, I know it's hard to do this in your head. I even struggle with this, but again, we're in 0 index notation. And so to get the 5th element, you have to put a 4 in here. You can also use slice notation as well on characters. So let's say that I want to get everything from the 4th letter to the end of the string in increments of, or in steps of 2. So that would be the 4th letter, steps of 2. So we've got L space O L exclamation point. Not that anyone would actually do this really in real life, but it's kind of good to know that this does work. What's more common, though, is this sort of notation here, where one might want to be able to take, oh, sorry, I see there's a mistake here. Whoops. Okay, I'll go back to that in a second. So where one might want to be able to take a string like this and split it up into a list of words. And so we can do that with the dot split method. This works on any string. And what it basically does is it takes that string, breaks it up into a list, and it does that based on a separator. In this case, we want the separator to be blank space, a space like this. When we do this, we can see how it splits it up. We could have also set the separator equal to, for example, the letter A. And now you can see that it split it by the letter A. Okay, so it can be any character, doesn't have to be a space. It's just often we want to split things up into words. You can also rejoin a list into a string using the dot join. Okay. Basically, one thing that's, I'm going to just really quickly explain here. One thing that's a little bit confusing to understand is that this is a method from objects belonging to the string class. So let's say that we wanted to take this list of words and we wanted to join it back into this sentence by adding back in the separator, which was a space. Well, the way we would do that in Python is just to take this separator, which is just a space, as a character, and then do the dot join method on this separator, and then use this list of words. I know that's a bit convoluted, but you can see it does work. And in fact, the separator could have been anything. You know, or for example here, that wasn't supposed to be there. For example here, it can be a weird emoji face. Could be anything. Okay. So this is sort of me tacking back on to the end of the list lecture, but I'm doing that because we're going to need to be able to use some of these approaches later on in the challenge problems and also in the homework. All right, anybody have any questions about this so far? Okay, well then I'm going to move on to what is a fairly obligatory part of any programming course, which is flow control and functions. So I've called this section Other Programming Concepts in Python because the thing is, you know, most of what we do in data science isn't going to require a whole lot of really hardcore programming in Python, but it is still important to know how these things work, even if the number of times you use them will be relatively small compared to someone who's an actual Python programmer writing software in Python. That being said, let's go ahead and jump in to the first one, which is if, elif, else. Okay, so the if statement is basically just a statement in Python that creates what we would call a logic gate, right? So this is what we're talking about with control flow here, right? The code can only be reached if a condition is met, a logical condition. In this case, let's say that A is 1 and B is 1. We create a logic gate here. If A equal to B, and only if this is true, does the code inside the if statement get executed. Now, in this case, A is equal to B. We know that that is true. Therefore, the code inside here gets executed. If we set B equal to 2, for example, it does not get executed now. And that's because it is a logic gate that only opens when the condition is met, right? Basically, when this returns true. Okay. All right, so I don't know why this is said this. All right, I need to bug test this a little bit more, it looks like. I was probably not supposed to show you that example. Sorry about that. I asked here, can you modify the block above so that the code will not execute? That's kind of a wimpy example. But let's say this. Can you modify the block above so that the code will not execute given that A and B are not changed? So that's my challenge to you. Don't change A or B, but modify this block so that this will no longer execute. Can anyone tell me how you would do that? There's actually many ways you could. Yeah. Okay. All right, that's good. That's good. All right, very good. So the way we could do that is by taking this block, and instead of the way it is here, we could just set it to not equal. And we can see it no longer executes. All right. So if statements are pretty useful in a lot of programming in Python, but they become a lot more useful when we start using else along with it. So let's look at now the if-else statement. Now, an else is basically a part of an if statement that gets executed if nothing above it was true. If none of the logic gates opened, this is what happens, right? So if A equal to B, now if this is not satisfied, if this condition does not get satisfied, then else will run. Okay, so A is 1, B is 2. Therefore, we know A is not equal to B. Therefore, the else should run. And we see here that in the else, we see A is not equal to B, and we can see that is what was in the else statement. So the else did run. If we set this equal, then the else does not run. The else only runs when the statements above were not run. And this is why we call this control flow, because if you imagine it, you're going down here, kind of going from top to bottom. You reach the first if gate. If you were able to open it, then you go in here and you stop. Okay, if you were not able to open it, then you go to the next one, which is the print A is not equal to B. Okay, so that's why we say control flow, because if you imagine it going forward from top to bottom, that's kind of the way I personally think about it. All right, go ahead and see if you can run this challenge without actually running it yourself. I don't know why this is in here. Oh, I know what happened. I made a mistake when I was rendering the notebook. But yeah, go ahead and without running this, pretend like this isn't here. Without running this, what will this print? Okay, so see, 2 people said yes. Okay. All right, very good. It is yes. And the reason is because if you look at it here, we see that the second element, again, thinking in zero notation, the second element of A is a 2, therefore 2 equal to 2. This is true if true. So when we say if true, that means the gate is going to open, and we'll say print yes, right? So we run this and we see, in fact, that is what it says. Just as an aside, if you have an if statement like this, if true, print A else print B. Is there any situation in which print B can execute? Just out of curiosity, does anybody know? Well, sure, you could modify it. You could modify it, but I guess my point would be you would have to basically do something like this in order for this first part to not execute. Basically, if you have if true, that means that no matter what, this is going to execute. Because if true is basically an open gate, a constitutively open gate. So it has to be a no matter what you do, because if true basically just means do this thing, else will never execute. All right. So let's move on to elif. Now, elif is basically a way of chaining together multiple if statements. And again, think of it like you're flowing down the list of code lines here. Let's say that grade is equal to 78. We have this first part. It says if grade is greater than 90, execute this code, okay? And if not, then you go to the next one. Basically, elif is a way of saying else if, right? If this doesn't execute, then try this. If this doesn't execute, then try this, and so on and so forth until you get all the way to the else at the bottom. Now, this code is basically going to take a letter grade, and it's going to check if that grade is greater than 90. If it is, it's going to give it an A. If the grade is greater than 80, it's going to be a B. Greater than 70, it's going to get a C. If it's greater than or equal to 60, it's going to get a D. And if none of these, it's going to be an F. If we run this, we see student earned a grade of C. I guess this is the American grading system. I'm not sure if the US is the only ones who use the system like this, but basically this is how most people grade, converting numerical grades in a course to letter grades. What's important to note here is that because of the flow control, okay, because of the flow control, it is not possible that a letter grade of 95 would ever get assigned to an F, because before you can even reach the else at the bottom, the if at the beginning will execute, and therefore the whole thing will stop, right? So just keeping in mind that you're only going forward to the next statement if the previous one failed to execute. All right. Okay, I don't understand what happened here. All right. What will the following print? Try doing this without running it yourself. Sorry about the issues with the notebook. That's my bad. Don't know how that happened. All right, so can you tell me what this will print? Without running it yourself. Okay, so we got a couple people said pine trees. Okay. Any other answers? Okay. Someone said cherry trees. Okay. All right, any other answers? This was a particularly hard one, so take a second to look it over. Okay, almost now says not pine trees. Okay. We'll give another 20 or so seconds on this one. Just going to give people a chance to look through it. This was a particularly hard one. Combines a lot of stuff that we talked about so far. Okay, any other guesses before we go through the answer? Okay, so let's go through the answer here. All right, so if we look at our list of trees here, we see that these are all kind of lowercase, correctly spelled, I think, trees. They were intended to be correctly spelled. All right, so the first part of the if statement, let's start from the top here, says pi plus space ne in trees. Now we know that this is going to produce a word that looks like this, just so you can see here, pi space ne. Now this is actually not in our list because we have pine, but we don't have this pi space ne. Okay. All right. So we know the first one is going to be false. So we now go to the next part. Now this one got a little bit trickier. We said comma dot join, and then we said fir and oak. Now, if we recall correctly, this is basically going to take these two elements of this list, and it's going to put them together in one string with this string being the separator. But you'll notice, again, paying attention to spaces here, okay, paying attention to spaces here, that there's no spaces here, right? So if we try this, it's going to produce something that looks like this, without any spaces. However, we said equal to this one with spaces in it, okay? So we know this one's not going to execute. All right, well, let's go to the next one. Now we have a blank delimiter. What does that mean? Well, it basically means that you're going to join two strings together, but there's not going to be any delimiter between them because the delimiter is just empty. All right, so we have ry and cher, but they're in a list, and that list is being reversed because if you recall, this is the way you reverse the order of a list. So we actually have cher and then ry being joined by nothing, which is just the word cherry. And we can see here that cherry is in our list. So that means that this one will be executed. So this was a particularly hard one. Props to everyone who got it. Props to everyone who tried. I mean, just thinking through these problems is very difficult. Go ahead and run this. Oh, whoops. Did I make a mistake here? Oh, I didn't put the, I forgot to include this part. All right. We see it does produce cherry trees. Okay, so great work. Hopefully this kind of and the in trees in the last elif is not necessary. In trees at the last elif is not necessary. It isn't? Well, I think it might be. I mean, it should be, right? Maybe you can explain for me a little bit more there, because it's a test of whether or not it's inside of the list. I think it is. I could be wrong though. What definitely isn't necessary is this else, for sure. If we take this out, okay. So all right, let's talk about this for a second. Okay. So if you, okay, funny thing about kind of dynamically typed, I guess that's what they're called, languages like Python, is that sometimes, without telling you, Python is going to try to think for you. Unfortunately, it's not always clear when that's happening, but it really can do things that are not expected. It can produce unexpected behavior. So for example, so Anna pointed out something really cool, which is that if you take out, so we said this is how you get cherry trees, but if you take out this in trees here, it still seems to work and produce cherry trees. Why is that? Well, let's take a closer look here at this. Because we can see if you take out in trees after this first part too, this also works. Why is that? Well, let's take a look here. If we put if hello world, whoops, print hello, we can see that somehow the if statement is interpreting hello world as a true. Right? So unfortunately, this is, again, one of those situations where Python is trying to think for you and is trying to interpret what you meant. I think this is because if you try to convert a string to a Boolean, it converts to true. Yeah. As Dan says, anything other than 0 can be converted to a true. Yeah, and so this is just a really tricky sort of situation where you got to be careful about these type conversions. They're really annoying sometimes. Yeah, so as Dan says, anything other than a 0 will be converted to a true. So there's actually an implicit Boolean conversion in here, just like there was here and just like there was here. So that's why you got to be careful and try to never supply like a character or an integer to an if or an elif without being super cognizant of what you're doing, because that has a huge potential to do a Boolean conversion without you wanting it to, right? Hopefully that kind of explains what happened here. So sure, we can take out the in trees and it will execute this cherry trees part, but that's not because this is actually doing anything. It would have done the same thing with any random string or any number greater than 0. So do bear that in mind. If you're trying to get the expected behavior, you want to really be careful about how you write these elifs and ifs and elses. Okay, any questions on that? That was a really great thing to bring up. I'm really glad you brought that up, actually, because that's a really confusing point that you will probably run into inadvertently at some point. Okay, great. All right, so let's go ahead now to loops. Now, loops are basically a coding pattern you can use in Python to iterate through an iterable object. So a list, for example, or a range, or there's actually other types as well, but we're just gonna think about those for right now. And you're going to go through this iterable object. You're going to take every element from that object, and in a for loop, which is the kind we're going to talk about today, you're going to take every element of that object, you're going to assign that element to a variable, and then you're going to do something with that variable. In this case, we're going to take every element in succession from numbers, we're going to assign it in succession to the variable number, and then we're going to print that number. When we run this, we see basically what the behavior is. Took every element from the list, did something to it, in this case, just printed it. We call this iteration, right? And we call numbers an iterable object because it's something that you can go through iteratively. All right, so instead of just printing the number, we could have done something to it. In this case, we could add 10 to it. This coding pattern can be a particularly convenient way to append or to create a new list. Okay, so remember the append method for lists. It's a way of adding something on to the end of a list. If we initialize an empty list here called new numbers, if we go through every number in numbers, we can append to new numbers that number plus 10. Okay, so that might sound a little bit confusing. That's because this is sort of a confusing way to do this. It's not how we would actually do this. And we'll talk in a minute about list comprehension. But for right now, just know that this is a way you can do this. And basically, this creates new numbers, which is a list of the same size as numbers, but which has all of the elements of numbers plus 10. And you can see that right here. Okay. We can now combine our loops and if else. Okay, so now thinking about the if else we had earlier, where we converted numerical grades to letter grades. If we take a list of numerical grades and we iterate over it, we take every element from this list and then we figure out what's the letter grade that goes along with it. We can easily see how each of these converts to a letter grade. So basically, go through the first one, it's an 85. That 85 gets assigned to the variable grade, and therefore we end up at the bottom printing the converted letter grade from that. And so on and so forth through the rest of the list. So 85B, 98A, 45F, 73C. Okay, before we do this challenge problem, anybody have any questions on how this is working here? Okay. Well, let's go on to the challenge problem then. All right, so without running this, okay, without running this, what will this produce? I've thrown in something new here that I didn't actually explain, but hopefully from context, you can kind of pick up on what this is. I'm going to give a little bit longer for this one. It's a bit of a challenge. So let's give a minute for this. Okay, so we got a couple answers now. I'm going to give just a second longer here. Okay, all right, very good, very good. All right, so a lot of people said kiwi, starfruit, grape. Let's actually see here. So how should we think through this? So we've got our list, our iterable, and we've got our new list that we've initialized here. Okay, we said for fruit and fruits. Now this is fruits. So for fruit and fruits, if I in fruit. Now recall that we can treat this in statement as a way of testing whether or not a specific letter is inside of a string, right? So if you have any of these that have I in them, this will trigger. Okay, so if I in fruit. Now, no I, no I, no I, there's an I here. Okay, so kiwi is going to be one of them, right? And starfruit's going to be another one. Okay, so both of those are going to be in there. And then I see where the typo is now. Thank you, Simon. Now we also said elif G in fruit. Okay, so where is there a G? There's a G in orange and there's a G in grape. Okay, so let's actually go through this in order. So this is not going to get appended. This isn't. This isn't. This is. this is going to go through the first part and then hit the elif. So let's say that we're now on the orange, right? So we're going through this in order. We're now on the orange. All right, so we said if G in fruit. Okay, so G is in here, so we're going to execute all the code inside here. Now, the next part says if P in fruit. Okay, well, there's no P in here, which means we're going to keep on going because a nested if is basically, like we said before, it's going to execute all the code inside of the elif is going to get executed. We have a nested if in here. This is basically just going to be another if that gets executed for this one element, or for this one element of the list that happened to trigger the elif. All right, so no P in here, which means we go back to the top. All right, tomato, nothing. Starfruit gets the I, and then grape, we get down here to the G. Okay, it executes this, which means we get down here to the next nested if, and there is a P in grape, so that means that grape gets all the way to the end and gets appended. And that's why you get the kiwi, starfruit, grape. Of course, this is incorrectly spelled. My bad. Kiwi, starfruit, grape. Any questions on this? I think it was only Adam and Liju who got it. Who actually got the typo. Very good. That was extra precise. Adam asks, what would you have one that was called pine grape? Would the G need to come before the P to be pulled up? No. So the in operator doesn't care about the order. It's just asking if that element exists at all inside of that iterable object, right? So if that G is anywhere in the string, it will be returning true, right? And we can show that here. We can actually just add that here to demonstrate that. But yes, that will still be true. Oh, wait, are you asking if it was capitalized as well? Because you also capitalized it. I'm just going to do it without the capitalized because that's going to be a whole other story. But yeah, again, Python is case sensitive, right? So we make this an uppercase G. Well, I was wrong. Oh God, this is like Python thinking for us again. Okay, so I guess, oh, that's annoying. I guess Python is able to think for us also with capitalization as well. Oh, right, because it's because of the I. Oh, okay, never mind. Sorry, like flailing around here. Okay, it doesn't handle caps. Okay, so if it was like this, it wouldn't get added, but it was the I that made it go. Yeah, okay, thank you. Yeah, you can mess around with stuff like this, but basically you can see it's like a waterfall. If you get to the first part and the I is there, then it's not even going to care about the rest of this. None of this is going to matter. But if the I isn't there, then you'll get to that second part and you have to have the G in the correct case for this to execute, and then you have to have the P in the correct case for this to execute. But it doesn't matter where in the string those are, it just has to be there at all. All right, anyways, so lots of fun. Let's move on here. So integer indexing is a more common way in some kinds of problems to deal with for loops. And the reason is because sometimes you want the position of an element in a list rather than the actual element itself. And there's multiple reasons why you might want that, but let's just showcase here what that looks like. So we've got our typical thing here. So we say we've got a list of letters, and we say for letter and letter, print letter. Okay. If we look at the range of letters, we say it's 0 to 4. Okay, and that's because, or range of length of letters, because there's 4 elements in letters. And so we've got range 0 to 4, because if you recall how range works, if you just give it one integer, it's going to be everything from 0 until that integer. What we can actually do now is we can do a new list where we use for I in range length letters. Now, basically, this is going to make a range from 0 to 4. So it's a range of the same size as our list. And instead of using the actual elements of the list in the for loop, we're going to use the indexes, right? Because basically I, standing for index in this case, is matching the range of the list. And so if we take letters and we take I, this is basically our way of taking the element of that list which matches the index I and printing it. So this accomplishes the exact same thing we saw here, but in a slightly more roundabout way. And if we also printed I, you could see here what it's basically doing. So in our range, the first round through, I is equal to 0, which is the 0 index, which is the first element. Then I is equal to 1, which is the second element, right? Then I is equal to 2, which is the third element, and then 3, which is the fourth element. Okay, so why would we want to do this? This seems more convoluted. Well, there's actually a pretty good reason why. Let's say that we wanted to do this. We wanted to take not only the grades, but we also wanted to include the names of the students. Let's say we have two lists, one that holds the students and a corresponding list that holds their grades. So Alice got an 85, Kevin got a 98, etc. Now, what we want to do is we want to iterate through both of these lists, and for each element of grades matched to a student, we want to figure out what's the letter grade they got and then print the student's name, earned a grade of, and then the letter grade. So this enables us to do that because, as I think you've seen now, if you were iterating like this, where you're taking grade from grades, you wouldn't be able to get the student as well. Okay, or I mean, maybe you could, but you would have to come up with kind of a convoluted, hacky way to do it. This is a more straightforward way to get the elements from both with the corresponding indices. Okay, so before we move on to list comprehension, any questions on this? Okay, so let's move on to list comprehension now. Now, list comprehension can be a kind of a daunting subject at first, but it's actually, once you understand how it works, it's actually super easy and straightforward. It's very efficient, and it allows you to accomplish in one line of code many of the things that you would need to do with multiple lines of like a for loop or something like that. It's also a really handy way and really Pythonic way to do a lot of routine tasks in data science analysis. So I'm going to show you here how it works. Basically, just to understand a list comprehension, all you have to do is see this sort of formula right here. We say modify value, value for value in values. Okay, that might sound confusing, but just understand this. What we're doing is we're actually constructing a for loop, right? So if we have some, list containing values, we're going to take each value in values. Okay, and then we're going to do something to that value. We're going to run some code on it. We're going to modify it, for example. Okay, so this would be roughly equivalent to if you have a similar situation here doing Python for value in values, modify value. This would be kind of the analogous way to do this without just this inner part, without this. But the difference is that you're actually returning everything as a list. That's the big difference. And so it's actually more like this. New list equals list. New list dot append. It's more like this. So you can see already how being able to do this all in just one line is already quite powerful, but there's actually some more complicated stuff you can do with this that makes it even more useful. But just know that this is roughly equivalent to doing this. Okay. So let's take a look at a really simple example here. Let's say that we're saying for number in range 111, just return number. We're actually not modifying number at all here. So what does this do? Well, for every number in this range 1 to 11, not including 11, we just return the number. And that makes our list of numbers from 1 through 11, not inclusive. Okay, but we could have also modified number. We could have done something to it. So for example, we can add 10 to it. And now you can see we've got 11 through 20. Okay, so I want you now to go ahead and in this challenge problem, I want you to write a list comprehension, which converts each element of fruits to uppercase. And, you know, obviously returns it as a list. So it should be a list comprehension. And we'll give some time to do that. I know that's also a bit of a challenge there. And you can code for this one. So you see, it doesn't say that you can't code here. You can code on this one. So you can check to see if you're right. Okay, so we've got a few answers here. Okay. All right. Any other answers? Okay. Let's go ahead through this now. So what we want to do is write a list comprehension which converts each element of fruits to uppercase. Now, just to sort of build this from the beginning, let's do fruit for fruit in fruits. Okay, so we've got a few now. Okay, so let's actually go through this. So for fruit and fruits. Now this is sort of the for loop part. Now we know the left side of this should be fruit dot, and we should do something to it. So we're trying to, if we did it without anything, we see it just returns it as a list, but we want to convert it to uppercase. So let's do fruit dot upper. And that's how you would do it. So really good work. A couple of people said dot uppercase. I'm not sure if there's a dot uppercase method. There may be. I don't think there is. I think it's just dot upper. Okay, so any questions on this part before we move on? So you can kind of see the pattern here, which is you've got your for loop on the right side of it, and then you're basically taking, for every iteration, this fruit part gets reassigned, and then you can do something to it. Basically, this means that for every element of fruits, you're going to return a variable fruit, and you can do something to it and return the whole thing as a list. Hopefully this will make more sense as you go along. I know for me, it took probably, I don't know, 8 or 9 times of consistently using these list comprehensions to start feeling like it was really natural to write one. So no worries if you feel confused today. It honestly does take time to feel like this is a natural coding pattern. But once you get good at them, once you feel fast with these, it is like one of the most useful things you can just use when you need it. All right, so let's now talk about how you can incorporate conditionals into this. So you can actually incorporate if-else into this. So for example, if we take for number in numbers, which if you recall, our numbers are, where did this go? Well, they were all the way back up here, but if you forget what they are, you can do numbers here. It was 1 through 10. So we say for number in numbers. So we take this number, and now we're going to apply this if else to it. Now, the way this works is that you have if and then some condition. So in this case, we have number modulo 2 equals 0. So basically, we're just asking if the number is even. Now, unlike in a typical if else, the order is a little bit wonky. If this is true, then you do this. Okay, so I know this is a little bit backwards, but if this evaluates to true, then you do this. Else, you do this. So if else and list comprehensions is a bit confusing at first, but once you use it a few times, it'll start to feel natural. So you can see the result here, which is we went through every number in numbers, and then if it was even, so if this ended up being true, we took the negative, and else we just return the number. That's why you see 1, -2, 3, -4. And hopefully you can kind of see how powerful this can become in many situations where you need to do a quick modification on some list and return a list. All right, so now a challenge problem. Can you take the fruits and convert the elements that contain the letter E to uppercase? But only the elements that contain the letter E. So combining a few things we've done now. This is also a particularly hard one. So no, if you're not able to get these, don't worry. For real, like a lot of these questions are very difficult. And I think what's important, though, is that you're attempting them and you're learning about Python along the way, and that you come back later and see if you can figure it out by going through it. Okay. All right. Got a few answers here. Okay. Anyone else? Okay. All right. Okay. All right. Very good. Those are all correct. So what were the answers? No, you don't have to include anything else. Yeah, that was it. So it was basically, I asked you to do a list comprehension where you convert to uppercase only if the letter E is included. So let's first write the for loop part for fruit in fruits. Okay, now that we've got that, let's go to the left side of that. Let's write our if else part. So if E in fruit, right? So if E in fruit, okay, so that's basically what we want to do if the E is there, and that goes on the left side of this. I know this is a bit confusing at first, but you'll see over time this is not too bad. We're going to do fruit dot upper, else just return fruit. And basically the way that you return this is that, or basically the way that you understand this is that if E, or the way you could think about this in natural language is like convert it to uppercase if the E is in fruit, else just give back fruit for all the fruits in fruits. That's how I would say it in natural language. Oh, did I mess something up here? Fruit, I spelled fruit wrong again. Amal asked a really good question, which is, what about elifs? Or I assume that's what you're asking here. Right, like, well, I'll just tell in case that was what you're asking, but also because it's an important thing to recognize, there's not really a good way to add elifs into here. You can, there are some hacks you can use in order to do that. It's not particularly advisable though, because one of the powers of list comprehension is that it's very efficient. It's doing something different than a normal for loop would be doing or a normal if-else statement would be doing. And keeping it in this structure allows it to continue doing that very efficiently. So I would say use this in the narrow use cases where you want to do something like this. But if you find yourself needing something that requires an elif, and well, at that point, you probably want to do something else. What if you don't include an else at all? What if you skip fruits without E? Let's see. Invalid syntax. And that is because for list comprehensions in Python, that is a very specific structure they're looking for there. Okay. And that structure includes both the if and the else. I think there are ways you can get around this, but they're not actually list comprehension structure. They're actually a hack. So the list comprehension structure is going to include both the if and the else. And again, this is how you take advantage of that really efficient processing of list comprehensions in Python. Okay. All right. So any other questions on this before we move on? The reason I mention this is because I legit use these all the time, like really all the time. This pattern is extremely useful and ubiquitous in data science stuff. So good to just see it and get exposed to it because you're probably going to end up wanting to use this a lot. Also, it just makes your code so much easier to read than including a bunch of like multi-line for loops and if-else statements. All right, let's move on to functions. Functions are a type of object in Python, and basically they take an input and they return an output, or at the very least, they do something. They basically take an input and do something with it. So in this case, we define a function using this def square it being the name of that function. And then we say it's going to take an input x. And so this is just a structure of what a function looks like. So we've defined square it, which takes an input x. And then we say inside the function, what are we going to do with x? Well, we're going to take it to the second power. All right. And we call this function square it. If we look at the type of square it, we can see it is a function. Again, everything in Python's an object, even functions. Functions are objects. If we run square it on the input 5, it returns 25, or it prints 25, I should say. Now, in the function square it, we're not actually returning a value. We're just doing something. We're just printing that value, which means that if we set the output of square it equal to results, we see it prints 25 because that's what the function does. But if we print result, it says none. Okay, so interestingly, none is actually an object type in Python. It's kind of comparable to the null in R, if you're familiar with R. But basically it just means empty. There's nothing there. There's no value there. But it actually has a type. It is a none type object. Kind of just interesting tidbit. You'll see nuns pop up every once in a while. To actually return some value from our function, we need to use this pattern where we say return and then the thing we want to return. When we do that and then run square it, we can see that the result actually holds a value now, or it points to a value, I should say. Okay, so I've got two challenge problems here. They're both kind of difficult. But let's say the first one is create a function with one argument grade, which should be an integer. The argument should the function should convert grade to a letter grade and return this to the user. So this should have said the function. Sorry for my bad proofreading here. The second challenge problem is to use list comprehension, convert every element. Well, let's start with the first challenge problem. So go ahead and take a shot at this, and then we'll move on to the second one. And I'm going to give about a minute to, actually, I'm going to give 3 minutes to do this one. This is a pretty long one. I think if you do Shift Enter in the chat, you can do multi-line, or you can just copy and paste it into the chat. That's probably the easier way. So if you copy and paste from your, like if I take this and I paste it into the chat, see, it gives the whole thing. Hi, are you there? You can't hear? Can anyone else not hear?
I hear you.
So it should convert. Okay, so I think Sanas, your audio might be off. Yeah, so just merge, just so you know, so it should convert it to a letter grade, right? Not just convert it to a string, just so you know there. Okay. You're a very harsh grader, Anmol. Anmol's code says everything below an 80 is an F.
Grad school grading right there.
Yeah. Oh man, it related too much to that. Okay. All right, so let's go ahead and actually do this now. So basically, this said to define a function. So we can start by defining a function. We can call it anything we want, but we could call it grade converter if we wanted to. Doesn't matter what you call it. And we could say it takes a grade as an integer. Now, what it's going to do with this grade is it's going to convert it to a letter grade. Now, I'm lazy. Okay, so what I'm going to do is I'm just going to go back to earlier in this notebook, and I'm just going to copy this because, like, why would I rewrite this if you know I got the code right there, right? So there you go. And last part, we just have to return letter grade. Okay. And if you're not a lazy coder, you're doing it wrong. Exactly. All right, so let's test our function. Let's make sure this actually works. Grade converter. Let's give it a grade of 83. And it says it's a B. There you go. Yeah, I say this in like more advanced workshops, but truly never work harder than you have to. There is no bonus points for putting in more effort, and honestly, no one cares if you put in more effort, because actually when you put in more effort, you're often writing code that is harder to maintain and harder to understand. So if you can, at every point, try to find more efficient ways to do what you're doing. Try to find ways to take less lines of code and doesn't create as much what we call spaghetti code, right? And the people who are paying you, yeah, like Simon says, people who's paying you, it's a little bit of a waste of their time to have to decipher your spaghetti code. So try to do things cleanly, efficiently. And if it didn't take you long to write, that means it's not going to take as much time for someone else to read it. And that's a good thing. It's really a good thing. So unless there's a good reason, don't work harder than you have to. All right. So challenge problem number 2, a couple people actually put in answers to this already, but I'm going to give another minute for people to go ahead and do challenge problem number 2 here. All right. Any other? To answer your question, yes, it does. Be careful about your namespace, right? So you don't really want to name your list and your function the same thing because it's going to get overridden. Because how does Python know which one you mean, right? But yeah, in general, though, what you got there is right. So basically for challenge problem 2, what you're going to do is you're going to take these grades. Okay, and now we're going to do our nice list comprehension. Oh, okay. Wow. So that would be right if you could use elif like that in list comprehension. That would be correct if you, so Sanas, your answer would be correct if you could use elifs like that. Actually, I don't know, maybe there's a way to do that. I don't think that would work though, as far as I can tell. But what you could do instead is use the function that does that same switching statement there. So we've already defined our function up here, grade converter. So this is, all about how you, it's like the Tao of how you write code, right? Because we've now got a reusable function. And so instead of writing all of this nonsense out again, we can just use that function directly in our list comprehension. So for grade in grades, grade converter grade. And there you have it. Because again, we already defined that function up here so that we can use that function right here in our list comprehension. So we don't have to write out that whole messy nested, big if, elif, else statement again. All right. Any questions? Yeah. Okay. Yes. So match, like case switching and matches would be a much more efficient way to do this. Serge is right. So if you want to see Serge's, I'm going to put this. So for people in the video, I'm going to put this into the. No, that's actually great because we don't have any plans to talk about that later either. So basically, this is a more efficient way to do kind of accomplish the same thing we're accomplishing now with this coding pattern match case pattern here. Because I think, Serge, correct me if I'm wrong, but I think this is like vectorized, right? This is the vectorized form. Am I understanding that correctly? I don't know. Don't worry about it. It's definitely the preferred way to do this. But don't worry if you don't understand it right now. You can look this up and experiment with it on your own. Right, because these big waterfall, we call these, I guess people call them ladder ifs, but basically this is like really not the preferred way to do anything in Python. You usually want to use like a case switching statement that's more efficient. All right, so before we jump into more complex objects in Python, any questions on what we've talked about so far? Because this is the end of us talking about these sort of control flow function definitions, sort of like core programming concepts in Python. We're done really talking about how to program in Python for the most part. From here on out, it's basically objects and how to use data science-y methods on them. Okay, so let's move on here. All right, so we got through lists. Since last time I actually added modules and packages as a specific section of this. We're actually going to blaze right through dictionaries, tuples, and sets and get pretty quickly into modules and packages. But I would be remiss if I didn't talk about dictionaries, since dictionaries are the core object type of Python. In fact, everything is technically at some level built on dictionaries. They're kind of how you do definitions for things like classes and objects. And so I'll just show you here how they work. So a dictionary is between curly braces. So opening up curly braces makes a dictionary. And dictionaries, unlike lists, are not ordered. There is no order to a dictionary. A dictionary is built instead based on key value pairs. So the key in this case is hello. The value is 1. Okay, so this dictionary has one element and it holds the value 1, and you can access it through the key, which is hello. If anyone here is familiar with things like JSON or NoSQL, this will feel very familiar. Okay, so if we print my dict, that is hello 1. If we try to access the 1 value from this, we can do that using the key. The key gives us the value. There you have it. One more method I don't really include in here, but which could actually be useful in some of the stuff we're going to do later. There's this method called .items. And this gives you an iterable that includes tuples. So if you want to get the tuples from this, so if I wanted to do a quick list comprehension here, just so you know how we can start to practically apply this list comprehension method, key for key val in. So one really quick note about how you use list comprehensions with dictionary items. So I've got a tuple that's created here. If you want to get the elements from a tuple in a list comprehension, you do it like this: for key val, right? You don't have to call it key and val. You can call it whatever you want, but you separate them with a comma. And this creates, if you wanted to get a list containing all the keys in your dictionary, this would be how you would do it. Don't worry too much about this right now. This is really going to come in later on, but I wanted you to see from the beginning how you would use list comprehensions to work on dictionaries, because this is actually a pattern you'll probably see a few times during this workshop, if not at least as you start getting into data science. All right, so dictionaries can have numerical, string, and Boolean keys. They can hold any number of arbitrary object types. They can even hold, as you see here, dictionaries. So you can have nested dictionaries just like you can have nested lists. If we try to use the key true on this dictionary, it does return for us the dictionary new true that is nested within my dict. So just so you can see here, the accessing of things is done with keys, which return values. Does len work for a dictionary? I actually have no idea. Maybe. I kind of think not, but maybe it does. Len my dict. Oh, yeah, I guess it does. Cool. Nice. By the way, just considering this example above, maybe a slightly simpler one is to recognize that for dictionaries, you can use the keys method to get specifically just the keys. And you can use the values method to get specifically just the values. Not that I'm expecting you to be able to do this anytime soon, just so you can see if you did want to access these things, this might be how you would do it. Not that you have to be able to do this anytime soon, because you don't, just important to know for the future. Okay. All right. Sets and tuples, I'm not going to talk about them. If you want to look them up, they're both here. Tuples are kind of important in some aspects of Python programming, but we're really not going to be using them much here. Sets are also important in some aspects of Python programming, not really going to be using them much during the workshop. So it's not terribly important that you understand them in detail. If you want to look them up, you can go ahead and do that here. Let's move on now to modules and packages. So we're now getting back into the meat of what you're going to need to know for this workshop. So modules are actually just Python scripts. So these are actually files that are imported into Python. Typically, they contain functions or classes, and they're useful for your code. So the concept of modules can be really confusing at first. So don't worry if at first this doesn't make too much sense to you. I think it'll start to make sense over time as you start to use these more and more. One of the modules that is built in to Python is called built-ins. You can import the built-ins module using import built-ins. Built-ins is a generic Python module. It contains a lot of the core functions in Python, such as print. If we look at the type of built-ins, we can see it's a module. We can access the print method from inside the built-ins module using the .print, using this notation .print. Basically, this follows the structure module name dot function or method name that you want to get from that module, right? So something important to note about modules is that you can actually give them variables, right? So you can have a variable that refers to that module. So we can import built-ins as btns. So now this is a variable that refers to built-ins. And so instead of having to type out this whole word every time to use this print method, I can just do btns.print. And this works. And then finally, let's say that I don't want to actually have to import the entire built-ins module. Let's say I just want one function from it. I can do this structure here. From module name, import function. So from built-ins, import print. And this allows me to import just the print function from the built-ins module. Okay? Even further, you can alias or assign a variable to that function you imported. So we could say from built-ins import print as pnt. And that means now pnt is a variable referring to print, and you can use pnt like print. So I know this is kind of an arcane topic, but you're going to see all of these patterns at various points in your journey with Python. So I wanted to expose them to you here. Any questions on this? Why would you have to import print? Well, I think you know, Dan, why you might have to import. For anyone who missed the lecture from last time, the reason you might have to import print is because you can be dumb and you can overwrite print with something else, and now print no longer works. If you try to print hello world, it no longer works. And then if you want to fix this, all you have to do is come back here and do from built-ins import print, because that will reinstate print to its former glory as the correct thing you wanted it to be. Could you create a method? Is it similar with functions? So the difference between functions and methods is actually really interesting. I just don't have time to get into it, but maybe in the future we should talk about that. Yeah. Okay.
If you want to hang around after class, I'd be happy to talk to you about the difference between functions and methods. It's actually really interesting. But yeah.
Yeah. So we're approaching the end of the workshop. So end time is supposed to be 6:50, but I suspect we'll probably go slightly over time again. I feel like I'm terrible at keeping my promise to end on time, but especially in these early workshops, in these early sessions of the workshop, I think it's important to go through these aspects in detail. That being said, around 5 minutes before 6:50, I'm going to take a break and show you the homework. And so people who are not able to stick around past the end of the workshop can know what the homework is for next time. But for now, let's go forward to, okay, so we're going to get to NumPy arrays. First, I'm just going to show you how packages kind of work here. So packages are basically a collection of modules, all right? So for example, NumPy is a package, and NumPy contains a lot of modules. Scikit-learn is also a package. Pandas is also a package, and they contain a lot of modules. Now, to install a package, you'll usually use the pip package manager. Now, the way you use pip is typically from the command line, you'll type pip install and then the name of your package, and it will install it. So for example, if I'm in, if I pull up my command prompt here, I'm not sure I actually have, oh, okay, actually, sorry, this might not work for everyone who did Anaconda. If you go over here to Anaconda and you open up Anaconda prompt, if you do, pip install and then the name of some package, for example, Flask, it will go through and it will attempt to install it. I actually already have it on my computer, so it's not going to install it for me. But this is a very common way to install packages, right? However, we're in Jupyter Notebook. We don't have a command line in front of us. So how do we install things? Well, you could actually start by referring back to one of the things that makes Jupyter Notebook really great, which is that they allow you to execute any arbitrary command line commands from within Jupyter Notebook using this exclamation point notation. So if you put an exclamation point in front of something, it executes it as if it was a command line argument from the Anaconda PowerShell if you're on Windows, or Anaconda Shell if you're on Linux, or Anaconda Terminal if you're on Mac. So for example, I say echo hello world, which is a command line command, and it says back hello world, right? So this is not Python, this is actually command line. So this is actually, for me, I'm on Windows, this is PowerShell. All right, we can also do pip install. So let's say we want to do pip install NumPy. We can run it like this. And for me, it says I already have the package, but if you don't already have this package, it will install it for you right here. Okay. So let's go ahead to NumPy arrays. Okay, so I'm going to briefly go through some components of NumPy arrays, and we're going to save others for next time because we've already talked about a lot, and we don't want to overwhelm you guys for this week. But I at least want to give you a taste of what NumPy is about. So the very first thing we do here is we start by importing NumPy as NP. This is just a way for us to shorten. Again, this is just an alias or a variable referring to the NumPy module. So we don't have to type out NumPy every time. When we say here type NP, we see it is a module. Okay, so basically, and we've already talked about this here a little bit, but basically when you want to access a method from within an object, you just do object.method, and that's the notation. So if we want to, for example, use the array method from NumPy, we would just do numpy.array. Okay, so the reason that we are doing this here is because we're going to be building arrays with NumPy. That's the main thing we want to use NumPy for, is to build arrays and to do operations on them. So let's actually make an array here. And we can do that using a list containing 1, 2, 3. So what we've created is a one-dimensional array containing 1, 2, 3. Okay, we can also make two-dimensional arrays by using nested lists. So we see 1, 2, 3, 4, 5, 6. So we've got 2 rows and 3 columns. My bad here. Should have been NP. Oh, I accidentally undid all of this at the end. When I was working on this, it should be NP, not NumPy. So we've made a two-dimensional array here. And we can even make a 3-dimensional array. And actually, you can make arrays with as many dimensions as you want. You just have to keep nesting more and more lists. Okay, so we call these ND arrays or n-dimensional arrays, where n can be any arbitrary number. Okay. All right, so why would we want to do this? Well, let's get into a few of the methods associated with NumPy arrays. Let's start with how you create an array. So again, we can just do these nested lists to make one. So for example, here we've got a Boolean array. We see the type says it's an ND array, as we mentioned already. These are ND arrays, n-dimensional arrays. We can also use this np.arrange method to make a one-dimensional array. And np arrange is going to take, just like range does, and just like slice notation does, it's going to take a start, stop, and step. If we just supply one value, it's going to take everything from 0 to that value. So we've got an array containing everything from 0 to 10, non-inclusive. If we apply a start and a stop, it's going to include everything from the start to the stop, non-inclusive. And if we include a start, stop, and step, it does everything from the start to the stop, non-inclusive, in the step interval. So we've now got everything from 10 to 100 in steps of 5. And we can also make a float array by supplying a float here. So this takes everything from 0 to 10, non-inclusive, as floats. All right, so NumPy arrays have many properties associated with them, but one of the properties that we're going to talk about here is they have a number of dimensions and they have a shape. Okay, so unlike methods, properties which you access doing object.property_name do not have the parentheses after them because they're not a method, they're just a property. So let's construct a 2D array here, and let's get the property ndim, that's the number of dimensions. So it's a 2-dimensional array, so ndim is 2. Now let's get the shape of the array. Now the shape is going to follow a particular format. It's going to be a tuple, and it's going to follow this format. It's going to have the last dimension, the dimension that is the newest, or if you think about it in terms of the brackets, the outermost brackets, and the number of elements in that dimension, and then the next innermost, and then the next innermost, all the way to the most innermost dimension, which is the last set of brackets. Okay, so that might seem confusing at first. I'm going to keep repeating that because it is a thing that you will run across many times as we go through this, how this works in NumPy. So we see here that this array, this 2-dimensional array, has a shape 2, 3. So the innermost is dimension 1. The innermost is these rows that each contain 3 elements, which is why you see 3 here as the last element in the tuple. Okay. Now, the leftmost element here is the outermost set of brackets. These are your rows, and you can see we have 2 rows. So therefore, we see dimension 2, which is the rows, has 2 elements. Dimension 1, which is the columns, has 3 elements. So we see 2, 3. Okay, let's take a look at a 3D array now. All right. So now we've got a 3D array where we've got 2, 2, 3 shape. And that's because we've got 3, the innermost dimension is the columns, and that is 3 columns, so 3. And then we go out 1 layer to the rows, so 2 rows, 2. And then we go out to the final layer, final set of brackets, which we could call stacks of matrices. So basically, we would say there are 2 of these, and you can see them here. These are the 2 stacks. That's what makes this a 3D matrix, is that you have stacks of 2-dimensional matrices. And so we see 2 stacks, 2 rows, 3 columns. All right, so I had the hardest time understanding this at first. So let me pause here and take any questions that people have. Don't worry. We're going to be repeating this again next time as well, because this is a very central concept, is understanding how these work. Does a list have a shape? So I don't think so, but you can always check. So say my list is equal to 1, 2, 3, my list dot shape. So there is no shape inside of lists. So lists do not contain the shape property. And I think this is really just NumPy arrays that have this. Okay, so like I said, we're scheduled to end at 6:50. So for those people who need to leave right on time, let me go ahead and explain the homework. So considering we didn't get to everything here, some of the homework will actually be pushed to next time, and that's okay. That happens. We want to make sure we're going at a pace where we're going to be able to stay on track without losing anyone. But let's go through the homework. Okay, so if you go back to your if you go back to this module 2 folder in Jupyter Notebook, you can see this module 2 challenge problems.ipy notebook. And this is the homework here. So these are very difficult problems. These are perhaps even more difficult than a lot of the problems that you see in the challenge problems we do during class. But you have as much time as you need to work on these over the next week. And in fact, a lot of these you'll have 2 weeks to work on. And so what you're going to do is you're going to go through each of these challenges. So for example, this first one asks you to fix the type error here. This one asks you to write a function that returns the 3 largest and 2 smallest values in a list, and so on and so forth. Where things get a little bit more confusing is in question number 4. This asks you to write a function called analyze circle, which, given the radius of a circle, returns the circumference and area in a dictionary. Okay, so the dictionary would have keys like circumference or area and would have values associated with those keys. All right, next, even more confusing, is going to be 5. Given the text of Jane Austen's Pride and Prejudice novel, which is in this file, prideandprejudice.txt, determine the number of times the word the appears. Okay, so I've already got a little bit of code here to open that file and get the words as a list. Okay, so we've got all the words in the novel. Now we need to count the number of times the word the appears. And then from there, question 6 is construct a word count dictionary for all the words in the novel with this format. Term 1, term 2, and then the number of times that word appears. So all the words should be in this dictionary, and you should have the number of times that word appears in the novel. Okay. So questions 7 through 10 will be all related to using some mathematical methods from NumPy. So none of these will be for next time. So go ahead and for next time, these are due in 2 weeks. So these are due in 2 weeks, okay? So these are all really hard questions. You don't have to complete these. I'm saying do, but they're not actually due. You don't have any homework that you have to do. We're not giving you a grade here. But I would say it is really, really worth your time to really give it your best shot to try to complete these, because these are excellent challenge problems that are going to teach you a lot about how Python works. Basically, you have a choice. You can spend the time and effort now to struggle with problems like this, or you can do it later in the workshop, or you can do it in your actual work later on. But at some point, there's a price in struggle that kind of has to be paid for you to be able to fully learn. I would really recommend to struggle in this environment where we can help you more than in later environments where you won't have quite as much help And you're always welcome to reach out to us. You're always welcome to come to our office hours, and we're always happy to help. But I would say before you do that, it's really worth your time to Google, just to spend time Googling. If you have a question, try Googling it and see what happens. So Amal asked, how do you submit homework? So if you can finish this or get as close as you can, send this to myself, and I'll get back to you on it, especially if there's any issues with it. But again, you're not required to turn in anything, but that's a service that we're offering to you. Send it to myself, or to Simon or to Dan, and we'll review it and get back to you. Okay. And we'll probably talk to each other over Slack, because we've got a Slack channel going, where we can go through it together. Okay. Serge mentioned Stack Overflow is a great place for tech issues. Absolutely. So yeah, if you've got an issue, so for example, if I Google the phrase type error Python, you'll pretty quickly find, there's a lot of Stack Overflows where people are talking about this kind of thing. In fact, there's one called How to Fix a Type Error in Python, where people have given their take on it. So if you run into an error, typically just Googling that error and the word Python will be enough to find information about it. All right. So we've now reached the end of the workshop. I'm going to stick around, and I'm actually going to, for this, keep going through. The videos go up the same night as we have these lectures. So within a couple of hours, this lecture video will be up online. If there's anything that if you've got to go, anything that you miss will be in that video later tonight. So feel free to go back and rewatch any parts that you missed. Okay, so now that the homework has been explained, I'm going to go ahead through just a couple really quick things additionally in Numpy, because even though we are going to talk about them again next time, I want to expose to these concepts before next time. Oh, and Simon says, know that if you come to us with some weird error, we will 100% copy and paste your error into Google to find the answer. Save yourself an email chain and Google it first, then come to us if you can't find the answer or have questions about it. 100% concur. That is actually how I troubleshoot everything in Python and in R, and actually just anything with computers, just copying it into Google. Okay, so all right, see you, Dan. All right, so let's get back here to talking about the concept of how to construct these NumPy arrays. Okay, so we talked about how you can do NumPy arrange. This is going to make a one-dimensional NumPy array from 0 to 15, okay? What we can do then is we can do this reshape method that's going to take that array and it's going to force it into a into a shape that we specify. In this case, we have specified 5 rows and 3 columns. So let's take a look at that now. We can see now 5 rows, 3 columns. Okay, so this is a really useful way to take, for example, a one-dimensional array and force it into a particular shape that you want for it. You can also do this all in one line, so you can chain these together. This is actually identical to what we just did up here. Okay, so we're actually going to get to this challenge problem next time. Okay, let's talk about accessing elements, because we're going to actually start back up here next time and quickly review all this, and we're going to do this challenge problem. At least I think, if Simon wants to. Simon's going to be running it next time.
Sorry, totally missed what you just said. What am I doing?
Oh, yeah, if you want to do this challenge problem next time, I don't think we're going to have time to get to it today.
Yeah, for sure. I'll pick up wherever you leave off today and do the rest of your notebook before doing mine.
Okay, cool, cool. All right, so finally I want to talk about how you access elements. This is the last thing I want to get to today. All right, so accessing elements follows the exact same structure as the shape property does. It's got the outermost dimension, dim n, all the way to the innermost dimension like this. So if I want to access, for example, in a one-dimensional array, if I want to access the second element, I would do it like so. This gives me the second element from this one-dimensional array. Now let's say instead I've got a two-dimensional array and I want to access the first element in the second element in the columns and the first element in the rows. So I want to know what is the value in column 2, row 1. And that's 7. So column 2, row 1, 7. And again, that's just moving from outermost brackets. Okay, so the rows are the outermost brackets, so we specify those first. Then the innermost brackets are the columns, so we specify that second. Okay? Rows, columns. If you'll notice, for R people, this is kind of the same way we do it in R. All right, now in a 3D array with 3 dimensions, so outermost being the stacks, then rows, and then columns, what if we wanted to, and so we build this here, right? So we built this using the reshape command. Okay, 5 stacks, 5 rows, 5 columns, arranging the numbers from 0 to 125, non-inclusive. What if we wanted to access the second stack, third row, first column? So second stack is this one. Third stack, fourth row, second column. I'm terrible at thinking in 0 index. All right, so third stack, fourth row, second column. Should be 66. And that's basically how you do it. Last part here I'll say is that you can also use slice notation. So let's say that you wanted to get everything in the first stack, or sorry, you wanted to take the first stack, get everything in all the rows, but within the first column. So basically what would that mean? That would be here in the first stack, okay, all the rows. So we're taking all the rows, but we're only taking everything in the, in the second column. I'm terrible at this 0 notation. Second column. 1, 6, 11, 16, 21. 1, 6, 11, 16, 21. All right, so this is taking all the rows. If we wanted to take all the columns as well, it would look like this. We want to take just the first row, all the columns, or just the second row, all the columns. It would look like that, so on and so forth. All right, I wanted to do this because the concept of dimensions and shape is really confusing in NumPy at first, and I want to get you exposed to it this week and next week, so that by the time you get to it next week, it already feels less confusing and overwhelming. If you want to look through the rest of this and start on those challenge problems, you are so welcome to do that. But if you feel like you're already feeling overwhelmed, don't worry about it. Go ahead and just go back to finishing those first 6 challenge problems and see if you can get those done. There's also review problems on DataCamp that are truly excellent for NumPy and NumPy arrays. So feel free to go back and review those as well. And again, we've got office hours in the syllabus. If you run into any issues or you have any questions at any point, you are more than welcome to reach out there. Okay, so with all that being said, any last minute questions that people want to ask here? Catherine asked, what are these arrays useful for? Can you give an example for a real life application? There are so many uses for these. These are like really, really fundamental stuff. This is like a very fundamental in data science, especially sort of data structure. But just as an example, if we talk about an image, pixels in an image are just a matrix, right? And each pixel is basically a cell in the matrix and it has a value, right? So basically, you can use a NumPy array, create a 2-dimensional matrix, and each element basically represents a pixel in the image and it's got a certain value associated with it. For example, brightness would be an example of this. You could have a 3D matrix where you have one of the matrices is brightness, another one is red value, another one is green value, another one is blue value. So like that would be an example of how you might use one of these for a real world application. Okay. Any other questions? If you got to go, no problem. Okay. Simon, did you want to hang on and do for the lecture video that we'll post online a quick explanation of the difference between the functions and the modules?
Sure. So this is going to be off the top of my head. So the difference between a function and a method is that a method is a special type of function. A method is a function that belongs to a certain type of object. So a certain class of object. Say string.upper, right? We use the upper method to convert a string into all uppercase strings. So upper is a function that only exists as part of the string class. So upper, if you just type what I'm putting in chat right now.
Here, I can share my notebook and show this as an example.
Okay. If you just type upper brackets, right? Like just upper.
Right.
With anything. Upper is not defined. There is no such thing as a function called upper, but if you write quote unquote a.upper, let's actually see if that works. There you go. Now upper is defined because it is, we specify to Python that upper, it's supposed to look for the definition of the function upper in the object of class string.
Right.
So basically, methods are special types of functions that only belong to one type of object. And actually, expanding on that concept, attributes are special types of objects that only belong to other objects, such as the attribute shape of an object of type NP array. And note that you're accessing this with the same notation except without parentheses, because the open and close parenthesis tells, tuple is not callable, whatever. Let's not get into that right now. The open and close parenthesis that we used in upper tells Python that that upper is supposed to be treated as a function, whereas if we don't supply parentheses, it's telling Python that it's supposed to be an object. So an object belonging to a certain type of object is called an attribute, such as shape, because shape doesn't do anything. Shape just has a value, right? It's just an object that belongs to your array that has a value, in this case, 555. Whereas upper is, in fact, a function that does something. So that's the difference between a function and a regular variable.
If you want to see what's available for a particular object, you can just press tab after that dot, and there will be eventually you'll find all of the things that are available for this. So for example, well, actually, this is a mix of, unfortunately, this is a mix of both properties and methods. But for example, one of the properties is the size, the shape, the T is to transpose. So I guess, for example, size 125, because there's 125 elements.
Yeah. So anything, so object.object is a really important notation type in Python. And whenever you use that dot, it's telling Python to go look for the thing that you're asking it for in the object to the left of the dot.
Right.
So yeah.
One thing you can do that is kind of cool is you can actually, I'm going to do this on a simpler object type. I'm going to do this on Booleans. So dir is a function that allows you to see what is contained inside of a particular object in terms of the properties and methods and that sort of thing. So there's actually quite a bit in here. There's a lot inside of Booleans. You have, oh, wow. Okay, so these are all methods and properties for this Boolean. Wow, I have no idea what a lot of these are actually. Let's do it. Let's do strings. That might actually be simpler.
Nope.
No. Okay, but you can see here's split, for example, that we talked about before. And a few other things. Upper is here as well. There's also lower if you want to convert to lowercase. Join. Yeah. Anyways, if you want to see everything that's contained inside an object, dir is a really good way to do that.
Well,
anything else you wanted to say about difference between methods and functions?
No, a method is just a special type of function in that it belongs to only one type of object. That is the long and the short of it. Sorry for my rambly explanation, but thanks to YouTube, you can scroll back and forth through it and have me explain it a million times until it sinks in.
Yeah. Well, okay, everyone. It looks like there were no other questions. So let's go ahead and leave off here and see if you can't get done the first 6 problems before next time. If you run into any issues, feel free to reach out to any of us at any point. And yeah, we'll look forward to picking this up again next week. All right. Thanks, everyone.